Hi everyone. So today we're gonna talk about an analysis of once in a lifetime Morocco earthquake. Uh, is Al Haouz earthquake. So 49 minutes before midnight on September 8, 2023, a strong magnitude 6.8 earthquake struck a populated area of central western Morocco. This is a once in a generation earthquake for Morocco, and the US Geological Survey timed the quake just after 11 o'clock at local time on Friday, 8 September, with an epicenter near the town of Adasil in the high Atlas Mountains. An aftershock with a magnitude of 4.9 was recorded just 19 minutes later. The main shock was relatively shallow, just 18 km below the surface, as a result is likely to have caused damage across a wide area. So what caused the real deadly earthquake in Morocco? So earthquakes are commonly caused along the seam where two tectonic plates move against each other, and in Morocco earthquakes mostly happened when the Africa and Eurasia plates meet. But that boundary is to the north near Gibraltar, so tremors are usually closer to Tangier than Marrakech. Yet, this one was in Al Haouz province in the high Atlas Mountains, 75 kilometers southwest of Marrakech, the country's fourth largest city. So, how bad was this strong earthquake, and how rare was it, and what exactly caused it? So the first thing we're gonna talk about is what caused the earthquake. So far, the explanation is that the quake happened when a reverse fault, where the edge of the rock on one side of a fault slips under the other, occurred between the Moroccan and Iberian microplates, which are both part of the larger Africa plate. Reverse tectonic faults lay to the north of the Atlas Mountains and deep towards them at one point. During the earthquake, the edge that lies towards the mountains slid over the other, pushing the mountain side up, a knock-on consequence of built-up tension between the African and Eurasia plates over time. The faults can only hold the stress so much, and once in a while, a thousand of years, an earthquake happens as a mechanism to release the built-up stress. The most likely scenario now is that there will be aftershocks for weeks before seismic activity levels return to normal. The rate decreases with time. It doesn't mean that the strongest aftershock cannot happen 5 or 10 days after. We don't know that, but the frequency decreases with time. And the movement in the Earth's crust was on two levels, one closer to the surface and one deeper down. The resulting slipping and folding is known as décollement. Given the depth of the earthquake, it was most likely that the décollement started at the deeper level and more towards the surface. Now is how bad was it? So the quake left thousands of people homeless, forced many to evacuate, and prompted authorities to declare 3 days of mourning. And that house was the hardest hit area, but other provinces including Ouarzazate, Azilal, Shishawa and Taroudant, Marrakech were also dealt significant blows, and some remote villages were wiped out completely, and the rescue teams are facing challenges and others. So the third thing is how rare was this earthquake? So this was one of the deadliest earthquake registered in Morocco since 1960, when a 5.8 quick struck Agadir. That earthquake was of relatively lower magnitude and much as intense, but it inflicted a high number of casualties due to conditions at the time, including the lower structural integrity of buildings. Earthquakes with an intensity like this one are rare in the region, with a magnitude of 6.8 or higher event being recorded within 300 kilometers of the epicenter according to UAE's Geological Survey, as we can see here. Some mountains mean fault lines, but the North Atlas Fault is a complex fault system at least 100 kilometers long with several individual minor faults, which may not have all been mapped. Given that significant quakes will happen thousands of years apart, people living in the region may not sense that they are in a fault system, and even geological evidence can be eroded over time. The first question is why the Morocco earthquake was so destructive and deadly. So it was a bigger earthquake than this part of Morocco is used to it. Also relatively shallow, it was between 10 and 20 kilometers below the surface, and if the earthquake had been the same size but deeper down, the shaking at the surface would have been less intense and fewer buildings would have collapsed. But it was an exceptionally big earthquake for these regions. It's a long way from the plot boundaries, but the fundamental reason for the earthquake is Europe and Africa are colliding, and that the boundary between the plots is more or less blue than the Mediterranean. So here in the high Atlas Mountains, we are 300 or 400 kilometers south of that main plot down, but the still earth movements, that's one of the mountains, are there, and these are big earthquakes. So the earthquake in Morocco impacting Marrakesh and many other cities and villages in the high Atlas Mountains have caused devastating losses of life and injuries across the region. What we know is that more earthquakes than usual will continue to occur in the region surrounding Al Haouz in Morocco, and these aftershocks will decrease in frequency in the days, weeks, and months after the magnitude 6.8 earthquake, the main seismic event. These are likely to be dozens of aftershocks that may be felt in this area over the first weeks and months, while future aftershocks are most likely to be felt near where the previous aftershocks occurred. They may also be felt further away. The largest of aftershocks so far has been magnitude 4.9, but magnitude 5 and larger aftershocks are also possible over the next weeks, months, and beyond. About 1 in 20 earthquakes are followed by a similar sized or large earthquake within the first week. The chance goes down with time, but larger aftershocks can still occur months after the main shock.